Welcome. I think this is our sixth lesson in the atomic structure unit. We're taking up the Bohr atom, grounding excited states, and light. A little bit of background. If you remember, our friend Rutherford came up with a structure for the atom, which was fundamentally right. So it was mostly empty space. There was a positively charged, dense, positive nucleus at the center, and electrons were somewhere outside. Now, he knew the electrons were in motion, and this already opened up a problem that the physicists were well aware of, that when an electrical charge is traveling around, is in motion, it's going to be radiating energy as it circles. And as it circles, therefore, its orbit will become more and more shallow, and in almost no time, it would crash into the nucleus. All atoms doing that would mean that matter would be unstable, and of course, we know that matter is stable. So what's the solution to this problem? Well, Bohr reasoned, also based upon some evidence that he had gotten from studies of spectral lines, which we'll take up in the next unit, that electrons couldn't just be anywhere. They had to occupy specific regions, specific shells. So electrons occupied shells of specific energies. And with the first shell, the one that's closest to the nucleus, being lowest in energy. So recall, when you look at the structure of an atom, these are energy levels, these are shells. The first energy level is less energetic than the second. The third has more energy than the second. The fourth generally has more energy than the third. So an electron here would be lowest in energy. This electron is higher in energy. This electron is higher in energy. And this electron would have the most energy of them all. He said again that electrons could only occupy defined energy levels. And he would say that a given electron has a lowest energy state below which it cannot go. So if this is what we would call the ground state, notice that that's the lowest that the electron can go. There's no danger of the atom collapsing due to the electron falling into the nucleus. It just doesn't happen. That can't happen. So the ground state of an electron is its lowest energy state. But he reasoned that just because an electron had a state beneath which it could not go, it did not mean that it could not occupy a higher unoccupied state. So if this was your ground state, there was nothing stopping you from moving, so to speak, to the second or the third or the fourth or an outer energy level. He called any of those energy levels with more energy than the ground state excited states of the atom. The key, of course, to reaching an excited state would be the absorbing of energy, reached by absorbing energy from outside. So let's put all this together. There are two possible transitions you can make, understandably. I could make a transition from what he called the ground state, the lowest possible energy level for a specific electron. We'll call that ground. In this case, the ground state was the first energy level. And let's say that it absorbed I apologize. You may have heard that was a fire drill. So I was saying the following. There were two kinds of transitions. One would be from the ground state to an excited state. It could be second, third, or fourth energy level. And so there would be a transition from the ground to some excited state. But of course, that could only happen if energy came from outside and was absorbed by the atom. So put into a nice, neat little statement. When an electron makes a transition from the ground state to the excited state, energy is absorbed from outside. Well, of course, as we know, what goes up must come down. So at some point, no one can predict when a specific electron will make this transition. An electron that's in the excited state will return to a lower energy level, for example, all the way back down to the ground state. So in this case, the excited state electron makes a transition to, let's say, the ground state. In doing so, energy is released. And that energy could be released in a bunch of different forms, specifically in the form of light. That's normally what we're going to talk about, the form of electromagnetic radiation that we most care about in this course. So again, put into words, when an electron makes a transition from the excited state to the ground state, energy is released as light. This can also be put in these terms. Energy is released as light. Light can be expressed also as color. For example, if we have something called a flame test. It also can be light in the form of what we call spectral lines. And we could also talk about a distinct set of spectral lines called a bright line spectrum. I will call it quits for the bright line spectrum now. In the next lesson, we'll explain exactly how bright line spectra are produced and how they can be used practically. Thank you. Bye-bye. See you in the next lesson.